right, we start with the definition of a reference angle. Definition of a reference angle. The notation that we're going to use for a reference angle is this little guy right here. Kind of looks like a theta with a prime symbol after it. That will represent reference angle. And a reference angle is just our distance away from the x-axis. So how far your angle is away from the x-axis. Now, over here they give me a chart that shows me how I can find the reference angle in any quadrant. Honestly, it's just common sense if you think about it. Like, let's say that you were in the first quadrant and you were over here at like 30 degrees. How far away is 30 degrees from the x-axis? Well, it's 30 degrees away. So that's why it says that in the first quadrant, your angle will be the same as your reference angle, right? In the second quadrant, let's say that we were over here at like 170 degrees, right? The x-axis is 180 degrees. So if you're trying to figure out how far away you are from the x-axis, you're going to say 180 minus 170 to figure out you're 10 degrees away, right? Well, that's exactly what this formula says. Take 180 and subtract your angle, 170, and that'll give you your reference angle. If you're working with radians instead of degrees, then you can see we could use pi in the place of 180. If you're down here in your third quadrant, maybe your angle was 200 degrees. If you're trying to figure out how far 200 is away from this x-axis, the x-axis is 180. 200 is just 20 past 180, so that would be my reference angle. You can see the formula says then take your angle, 200, and subtract the 180, and that would give you that reference angle of 20. Or if you were working in radians, you would use pi instead of the 180. And then over here in the fourth quadrant, let's say I'm trying to figure out how far away 350 is from the x-axis. The x-axis is 360 degrees when I make a full revolution. So I could say 360 minus 350, and that would tell me that I'm 10 degrees away. And that's what this formula says as well. And of course, in radians, 2 pi is the same thing as 360. So I didn't write on here for you to memorize that chart for tonight because a lot of you will just use common sense to figure out how far away you are from the x-axis, and that will give you your reference angle. Also on our chart, I've included something that we've done a lot before. I've taken like pi divided by 2 and said that's 3.14 divided by 2, so that's 1.57. Or over here, pi is 3.14. Down here, 3 pi over 2 is 3 times 3.14 divided by 2, so that's 4.71. That's helpful if I'm trying to work with something like 5 radians. I don't know which formula to use if I don't know what quadrant I'm in. And so if it's 5 radians, it's easier to see, hey, that's down here in between 4.71 and 6.28, so that'd have to be in the fourth quadrant. Okay, so look at the first one. Example number 4, it tells us our angle is 300 degrees and it wants to know our reference angle. So how far is 300 away from the x-axis? 60 degrees, yeah. So 60 degrees away from the x-axis, so 60 is our reference angle. Look at the next one, 2.3. If I've got 2.3, there's no degree symbol there, so that has to be radians. So if I've got 2.3 radians, that's where I might want to use these numbers, 0, 1.57, 3.14. 2.3 would have to be right here in the second quadrant. So in the second quadrant, it says take pi and subtract your angle. So I'm going to take pi, 3.14, and I'm going to subtract my angle, 2.3, and that gives me my reference angle of 0.84. All right, look at the next one. The next one is negative 135. I don't like negative 135. I don't want to work with a negative angle if I don't have to. So how could I change that name? Add 360, right. I want to find a coterminal, so I'm going to add 360, and that gives me 225. That's a little easier to work with. All right, so if I want to find a reference angle for 225, I need to know what quadrant it's in. So where's 225? Third quadrant. So how far is 225 away from the x-axis? 45, right, because I can just say 225 minus 180, and that gives me 45. All right, look at the next one. For D, they give me theta is 3 pi over 4. What quadrant is 3 pi over 4? Second quadrant, right. So in the second quadrant, my formula is pi minus the angle. So I'm going to do pi minus 3 pi over 4. pi minus the angle. Gonna need a common denominator to subtract there. So I could say 4 pi over 4 minus 3 pi over 4, and I'll get pi over 4 from my reference angle. All right, look at the next one, 5 pi over 6. What quadrant is 5 pi over 6? Second quadrant. So again, using that same formula, pi minus 5 pi over 6. Going to need a common denominator, so 6 pi over 6 minus 5 pi over 6 will give me 1 pi over 6. Now, we don't say this very often, but this is one time where we're going to prefer to work in radians than in degrees, because finding a reference angle in radians is a lot easier than finding a reference angle in degrees. Here's why. If you have a multiple of pi over 6, pi over 4, or pi over 3, and those are the only ones we work with on the unit circle, right? So if you have a multiple of one of those, your reference angle will always be the pi over 6, pi over 4, or pi over 3. What do I mean by that? Well, look at the two we just did, okay? We had 3 pi over 4. It has a pi over 4 in it, and that ended up being its reference angle. Over here, we had 5 pi over 6. It had a pi over 6 in it. That ended up being its reference angle. So if you've got something that has, it doesn't matter if it's 23 pi over 4 is its reference angle. It can be a negative 72 pi over 4 is its reference angle. Now, that doesn't work with everything. It doesn't work if it's like pi over 12 or something like that. But for the three we work on, pi over 3, pi over 4, and pi over 6, if it's in there, that's your reference angle. Okay, why is that? Well, yesterday we talked about the idea that if you know the first quadrant values, you actually know the whole unit circle. The reason for that is reference angles. Because if I were to take the 30-degree angle that we have right here and make a 30, 60, 90 triangle out of it, all right, we talked yesterday about bring that value straight down, and you can see that's an x value of square root of 3 over 2. Bring that point straight over, and you can see that's a y value of 1/2. That's where that ordered pair comes from. If I take that triangle and I reflect it over across the y-axis, I get the exact same triangle. It has the exact same lengths. It's just going in a different direction. So that's why x is still the square root of 3 over 2. It's negative because it's going in an opposite direction, but the length is the same, and that's why y is still 1/2. Take it and reflect it into the third quadrant. Exact same values. The only thing that might change is the positive and negative. Reflect it across the x-axis here or across the y-axis here into the fourth quadrant. Exact same values. So it's based on the reference angle that this ordered pair that goes along with that 30-degree angle will be the same all the way around that triangle. It's because of reference angles that we can do that and why we get to use that little shortcut. Now, yesterday we talked about some ways that we could remember these values off of the unit circle. Here's that same diagram that we just saw on the last slide where you can see, okay, if I take that 30, 60, 90 triangle and I reflect it over and I reflect it down and I reflect it back over, it's the exact same triangle every time. That's why it creates the exact same ordered pair every time, other than positives and negatives changing. We could have the same discussion about a 45, 45, 90 triangle, that if we revolve it around, it's going to create those same ordered pairs that we saw yesterday in the middle. And we could have the same discussion about the 60-degree angle. So we said yesterday that if we know these 6 values, we can just reflect them around to create the rest of the values on the circle. That is because of the idea of reference angles. We also mentioned that the plus and minuses changed, but there was an easy way to keep straight where the trig functions were positive and where they were negative. We talked about all students take calculus. In the first quadrant, all are positive. So both sine and cosine were positive. Notice that all of these sine and cosine values are positive. In the second quadrant, students, only sine is positive, so that meant cosine was negative. So notice that all of our cosine values are negative, all of our sine values are positive. In the third quadrant, take, only tangent is positive, so that means cosine and sine are both negative, and every one of these values was negative. And in the fourth quadrant calculus, only cosine is positive, sine is negative. So notice that our cosine values were positive and our sine values were negative. So that gave us a way to keep the sign straight. Then, to give us an easy way to remember that first quadrant, we said that we could look at the numerators. The numerators are going to count up 0, 1, 2, 3. Similarly, over here, if we start with this 0, the numerators count up as well. 0, 1, 2, 3. So since my only choices are 1/2 square root of 3 over 2 and square root of 2 over 2, then it makes it very obvious which of those values to fill in. And that's an easy way that I can create that first quadrant. And then, as we've said, once you know the first quadrant, you can reflect it around to come up with all of those other values. Okay, so we go back to doing things that we've been doing for the past couple of sections. Find the cosine of 4 pi over 3. If I'm going to have 20 of these on my homework or on my test or my quiz, it is probably worth my taking the time to draw the unit circle, because at this point I should be able to draw the entire unit circle on my own. Okay, so it's going to take me maybe up to 5 minutes to draw out that unit circle on the top of my test. Is it worth 5 minutes of my time? If I have 20 of them to do, probably. If I have 2 of them to do, no. So it'd be nice if we had an alternative way that we could find trig functions of any angle on the circle without having to have the unit circle. That's what reference angles are going to do for us. Step number 1, if I want to find the value of a trig function of any angle, number 1, find that trig function of the reference angle. That'll give me the square root of 3 over 2, 1/2, or square root of 2 over 2 value that I need. Then the only thing I'll have to do is figure out whether it's positive or negative. And I can determine whether it's positive or negative based on the quadrant that it's in. So I'm looking at cosine 4 pi over 3. If I'm on a portion of the test or the quiz where I give you the unit circle, or you've already had to draw the unit circle for yourself, then just look at the unit circle and say, okay, where's 4 pi over 3? Here it is. What's the cosine value there? It's the x value, negative 1/2. I'm done. But if I'm on a portion where I don't have the unit circle drawn and I don't want to spend 5 minutes drawing it to answer 2 questions, here's what I could do. I could say, step number 1, I need to find whatever trig function, in this case it's cosine, I need to find the cosine of the reference angle. Okay, I need a reference angle. The reference angle for 4 pi over 3, it's got a pi over 3 in it, so the reference angle is going to be pi over 3. So step number 1, take the cosine of the reference angle. So I'm going to take the cosine of pi over 3. The easy way to do that is to draw the first quadrant somewhere on the top of my page. Now, if I do that shortcut little 0, 1, 2, 3 thing and 0, 1, 2, 3, I can probably draw this in about 30 seconds on the top of my paper, as opposed to 5 minutes on the unit circle. So if I take 30 seconds and I draw this on the top of my paper and they say, what's the cosine at pi over 3? I can come up here and say, there it is right there, 1/2. Then step number 2, I just need to figure out whether it's positive or negative. That depends on the quadrant that I'm in. If I have a unit circle to look at, it's really easy to see 4 pi over 3 is in the second quadrant. But if not, it might be a little harder to figure out. Here's something that might help. All right. I know that over here at pi, 3 pi over 3 had to reduce down to pi when we counted around by multiples of pi over 3. So if this was 3 pi over 3, if I back up 1 into the second quadrant, that would be 2 pi over 3, or if I go past it 1 into the third quadrant, that would be 4 pi over 3. We don't seem to have any trouble remembering pi over 3, that's the first quadrant, and the really big ones like 5 pi over 3 and 11 pi over 6 and 7 pi over 4, we're pretty good at figuring out those are in the fourth quadrant. But what's really hazy for us are these ones over here in the second and the third quadrant. So using this idea of a landmark right here of 3 pi over 3 will make it immediately clear whether it was less than that in the second quadrant or greater than that in the third quadrant. So this guy's in the third quadrant. So as soon as I know that I'm in the third quadrant, I can say all students take in the third quadrant, take tangent is positive, so that means cosine is negative. So I'm going to get a negative of what I got for the cosine of pi over 3, I'm going to get a negative 1/2. Now notice that's the exact same thing we got off of that unit circle in the very beginning, but I didn't have to draw the whole unit circle to get it. All right, look at another one of those. Tangent of negative 210. I don't like negative 210, so how do I change that? Add 360, and I'll get 150. If I'm on a portion of a test or a quiz where I have the unit circle, I've given it to you, or you've already drawn it, I would just look at it and go, okay, 150 is right here. I want the tangent value. Tangent is the sine value divided by the cosine value. So I'm going to have to do 1/2 divided by negative square root of 3 over 2. So I'll come up here and I'll say, okay, 1/2 divided by negative square root of 3 over 2. When we divide fractions, we invert and multiply. So I'm going to be multiplying by 2 square roots of 3. The 2's are going to drop each other out, and that'll just leave me with negative 1 over the square root of 3. Never going to leave a radical in the denominator, so I'm going to rationalize that. So there's my tangent value of negative square root of 3 over 3. All right, what if I didn't have the circle and I didn't want to take the time to draw it? Then I can use this two-step process. So step number 1, I'm going to find the trig function, in this case it's tangent, of the reference angle. So I need a reference angle for 150. How far away is 150 from the x-axis? 30 degrees, right. So my reference angle is 30. So step number 1, I need the tangent of the reference angle. I need the tangent of 30 degrees. So I could come up here to my little drawing that took me about 30 seconds to draw, and I could say, okay, at 30 degrees, the sine is 1/2 and the cosine is square root of 3 over 2. So I'll come over here and I'll say tangent is sine divided by cosine, 1/2 divided by square root of 3 over 2. Exact same work we did just a second ago, right? So I'm going to multiply by the reciprocal. I'll get 1 over the square root of 3, rationalize that, and I'll get square root of 3 over 3. So there's my value for tangent 30, square root of 3 over 3. Step number 2, I need to figure out if it's positive or negative, and that depends on the quadrant that it's in. So where is 150? What quadrant? Second. So if I'm in the second quadrant, all students, only sine is positive there. So that means that tangent is negative. So I'm going to get a negative square root of 3 over 3. Just a little side note here, just a suggestion. There are lots of times that they'll ask me for sine and cosine values, but they also ask me for a lot of tangent values. And it gets really old really fast sitting here doing these computations over and over and over again on a test. So the very first time they ask me to find a tangent value, like right here when we found the tangent of 30, as soon as I find it, I go ahead and add it in like another column out here on this chart. So I've got cosine, sine, and tangent. The middle one's really easy to find because if you do square root of 2 over 2 divided by square root of 2 over 2, you just get 1. And this guy up here, if I do sine divided by cosine, square root of 3 over 2 divided by 1/2, square root of 3 over 2 divided by 1/2, I would multiply by the reciprocal and I would just get the square root of 3. If you notice, the tangent at 30 and the tangent at 60 are just reciprocals of each other. See how over here, let me go back one. See how over here it was 1 over the square root of 3? But over here it's square root of 3 over 1. So that's the nice thing. The very first time they asked me to find a tangent, whichever one they asked me to find, like if they asked me to find square root of 3, then I can do its reciprocal down here. Or if they asked me to find square root of 3 over 3, I can put its reciprocal up here and then just the one in the center. And that way I don't end up on 5 different problems on the test doing this exact same computation over and over again and wasting my time. So just a suggestion. All right, example number 6. They tell me that theta is in the second quadrant and sine is equal to 1/3, and they want me to find a couple of trig values. If I look on my unit circle, there's not a 1/3 on there. I got 1/2 square root of 3 over 2, square root of 2 over, there's no 1/3. So if I can't solve it with the circle, remember there were 2 different ways we learned to do these trig functions. We did circles and we did triangles, right? Go back to a triangle. So I could say, okay, if I build a right triangle with this thing, sine is opposite over hypotenuse. So I can say, okay, opposite would be 1, hypotenuse would be 3. How do I find the other side? Pythagorean theorem, right. X squared plus y squared equals r squared, or a squared plus b squared equals c squared. All right, so we got b was equal to plus or minus 2 square roots of 2. I don't know whether it's positive or negative. It's going to depend on what quadrant that I'm in. We know the hypotenuse or the radius is always positive, but the other two legs can be positive or negative, so I'll have to worry about quadrant in just a minute. All right, so let's figure out our cosine. Cosine is adjacent over hypotenuse. So what are we going to get if we put adjacent over hypotenuse? Yeah, I'm going to get that 2 square roots of 2 over 3. I don't know if it's positive or negative, so let's figure that out in step number 2. Remember we said it's positive or negative based on the quadrant that it's in. So since they told me this was in the second quadrant, all students only sign is positive, so this cosine right here is going to be negative. So I'll get a negative 2 square roots of 2 over 3. All right, for tangent, same idea. I'm going to look at my triangle. What would the tangent value be from that triangle? Tangent's opposite over adjacent, so it would be
1 over plus or minus 2 square roots of 2.
Yes, 1 over 2 square roots of 2. And of course I'm going to rationalize that. So I'm going to take that square root of 2 and multiply top and bottom by the square root of 2, and that'd give me square root of 2 over 4. Then I got to figure out whether it's positive or negative. And we've already talked about in the second quadrant, only sign is positive, so tangent is going to be negative. So negative square root of 2 over 4. All right, example 7, we finally get back to our favorite things. Example 7 says, use a calculator to evaluate. So grab your calculator if you would. Look at example 7a. It says cotangent of 410 degrees. What mode are you going to be in? Degrees. Then it says sine negative 7. What mode are you going to be in? Radian. If there is not a degree symbol, you assume that it is radians. So they're going to have me jumping around and skipping a lot back and forth. So be sure that you are very careful of the mode. Remember to change on your graphing calculator. You go to mode and then scroll down to where you have your choice of degree and radian, and you can toggle back and forth between what you want. When you hit enter, it highlights the selected one. So for the first one, in degree mode, I don't have a cotangent button, so how do I put that in?
1 divided by tangent.
1 divided by tangent, perfect. So 1 over tangent 410 is going to give us 0.8391. All right, then the second one, we'll switch over to radian mode. I do have a sine button, so I can just type that one straight in and get 0.6570.